Good morning, everyone. I'm Oliver Gao. I'm the director of Cornell System Engineering Program, and I have been conducting these system conversations with our outstanding speakers that we bring to Cornell to give talks in our ASHRAE System Seminar Series. Today, I'm very delighted to have Dr. Bing Dong. And Bing is an associate professor in the Mechanical and Aerospace Engineering Department at Syracuse University, which is not too far away from Cornell. And he's also serving as Associate Director of the Syracuse Center of Excellence for Environment and Energy Systems. His research focuses on building energy efficiency, occupant behavior modeling at both the building and the urban scale. So of course, from buildings to grid interaction and building controls and also diagnostics. So Bing, it's great to have you here. So when I was doing some research online about your work, your work interests me a lot because while you are looking at the buildings, I look at transportation systems. So of course, I can see that your career, your research has evolved. So we're always joking, like professors. When we, of course, we started with our PhD, and then you go through pre-tenure, you work hard. But we, in our PhD research or in our pre-tenure, like a lot of people, we were expected to focus on a very small, tiny area and dig deeper and deeper to show that we are the best in this specific but tiny areas. And then, of course, as our career evolved, and also due to the nature of your own research, I can see that your career, your research has evolved throughout all these years. I think for me, and also I believe for people who will be watching this video, I think we're all interested in knowing more, learning more about you, and how your career got started and how your career evolved. And as a result, what's your view about the key societal challenges that we're facing nowadays? Yes, so please take it there.
Yeah, thank you, Oliver. Very great introduction. Yeah, so very nice very honored to get invited to give this conversation and seminar at Carnegie University. Yeah, so my initial research started with during my PhD studies. And at that time, I really focusing on smart building controls, very focused area, very small, very narrow. And we are, what is triggered my interest is, I found out that my colleagues and also my friends and during PhD study, they all arrived building at different time. So which kind of showing that different behaviors of different people. So then I was thinking like, okay, what if everybody's behavior is different? So how we can control the buildings more smarter or even more intelligent, right? So at that time, I learned a lot of, MPC, multiple controls, and how we can know the future of weather and also solar radiations can control the buildings. But now what if we know the people's pattern in the future? What if like we can know what's in the next 24 hours, where people are, where people located, which building people will be, can we better control buildings? So that is my initial start. So I started with very scoped, very narrowed down to measure the dynamics in one occupancy office space. So I put cameras, I put a bunch of sensors, try to understand people's behavior in one office space. And then I later on extend to one floor of a building. So that concluded my PhD study. So after that, I went to industry, United Technology Research Center for 2 years in doing research, doing some demonstration projects funded by Department of Defense and also Department of Energy. And then I go to University of Texas in San Antonio for my tenure track. So starting there, I'm thinking that, okay, what if I know the people's behavior in the whole building, what will happen? So I started to do experiments and also simulation studies to look at whole building energy dynamics and occupancy dynamics how the occupant interact with buildings. And then there's a lot of different types of buildings. So I start with office commercial buildings, and then I go to experiment in residential building, which is more fun because individual behavior is so different. Every house, how they use energy is so different. So I started a field implementation in few residential houses in San Antonio. And we, again, we install a bunch of sensors, temperature, humidity, motion sensors. We measure the energy usage. And we found out actually, even this within these 4 different houses, how people interact with thermostats are so different. So everybody using different thermostat schedules. They are not always set at 72, they are different. So this triggers my another interest, which is starting 2016. So I'm thinking about, okay, what if everybody using the thermostat differently? So what is impact on the smart grid? What if that, there's 1 million people, 1.5 million people in San Antonio, there's more than 500,000 houses, right? Individual houses. So what if 500,000 houses, they all control, they all sign up for the demand response program for utility companies? What is the impact on the smart grid? How will this change the operation of smart grid? So then I started to study the topic called buildings to grid integration in 2016. And then later on, Department of Energy also come out a program called GIB, Grid Interactive Efficient Buildings, which exactly studied the same concept. So what if the grid cannot generate enough power for today? How building can help the grid make it sure it's stable, right? So what if the grid generate more power today? How building can help? So we call it a flexible load from buildings. So this study actually is widely cited by many other studies, recent for the last 5 years. And we also collaborate with a few utility companies like CPS in the San Antonio, and also Salt River Power SRP in Arizona to look at a large scale smart meter data, to look at how people use energy devices at home, how we can come out different energy policies to so-called customize energy policies for different user behavior. And which I will show in my talk. It's very interesting. So we look at more than 200,000 smart meter data users of homes. They all have different patterns of how they use energy. And later on, when we talk about the adoption of PV and the battery system, so because a lot of state they come out the process to promote net zero energy building or net zero carbon emissions, right? So one of the strategies is to ask people to adopt installation of photovoltaics and the battery system. So we also study how that will impact on the grid side. So the common sense is, okay, if I install more PVs, if I install more batteries, that will reduce the grid overall generation, which is true, but it does not mean it will reduce the peak of the grid generation. So actually one of the studies, very interesting, shows the peak is still the same or even worse if you install the PV and batteries in the homes. So these are things involve multidisciplinary of, first of all, as mechanical engineers, we have to understand heat transfer thermodynamics of buildings, and then also involve controls expertise, which you have to you have to understand how to design advanced control systems. For the buildings, like there's 10,000 buildings, there's a million of the states, control states in the control system. And also how you integrate with a power system. You have to understand dynamics on the power system side. And then you have to have knowledge of social science, psychologists, because you want to study people's behavior. How people behave, can you predict? So it's it's very multidisciplinary, and I think it's really fits to the system engineering topic very well.
I think very interesting story how your career and how your research topic actually, it seems to me kind of went ahead of the curve. Like when you started doing something and later on some government agencies came out with even call for proposals to do that. Like seem like you were ahead of the curve. So in your work, I think you mentioned of course, the word smart, like many times, right? So it's kind of, that you talk about, smart buildings, smart grid, and smart cities. So, so in your mind, how do you, for example, how do you define? Of course, nothing so far in this world is ideal to you. Like kind of when you try to evaluate, smart buildings or smart city. So in your view, what would be your definition and your goal that you would call smart buildings and smart cities?
Yeah, that's a very good question. So let's start with the smart buildings. So we often think building is so dumb because it cannot, save energy by itself. You have to put some control algorithms to ask building save energy. So the smart building is not only save energy. So not only put the smart control algorithm, say the building should control at this temperature, should use this energy for the building HVAC system, lighting, appliances. You should also understand what people's need in these buildings. So it's not only to save energy, but also to make sure people feel comfortable in the buildings. And plus, because of pandemic, there's a third element, which is super important, which is indoor air quality. So right now we study how we can balance, or how building is smart enough to balance energy, comfort, and indoor air quality in the buildings. So if it is a building not smart enough, then the building will say, okay, in order to reduce infection risk in the buildings, I will use 100% outside air, flush the building. So everybody will have fresh air in the buildings. That's, you have lowest infection risk of a virus, right? But a smart building will say, okay, I don't need to do that. There's an equation, there's a calculation to tell me how much infection risk will be in the buildings. And I can smartly or intelligently control the outside air intake, but at the same time, I balance my energy efficiency and also the summer comfort in the buildings. So I think that is defined as smart building, which is understand what people's need. Now back to the smart grid. So the smart grid is, the ideal grid is, I know exactly how much I will generate for tomorrow. That's it. The total assumption in my grid will be ideally equal to total assumption or total generations from the power plant. So my grid will have a very stable frequency, very stable voltage, and I know that everything. Unfortunately, it's not the case. People even struggle to predict how much PV wind turbine will generate tomorrow, because we cannot predict solar, we cannot predict the wind. There's a lot of errors, there's a lot of uncertainties, right? So even 1% of error of the solar generation, which will bring a lot of risk on the grid, because grid frequency cannot exceed, even 1.1%. So the smart grid is, I know exactly what people is doing, how much energy from the buildings, how much energy from how much generation from the PVs, from the wind turbines, from other biodiesels, all these different energy resources. So I know that how I can balance my grid. Although I cannot predict 100% accuracy, I know how I control the rest I cannot predict. So that's why there's needed to be a smart or intelligent control strategy for the grid side, also for the building side, that can meet the grid need. So if I predict 1% off, so what building can do, right? So building can, some building can adjust the thermostat. Some building can turn off the AC, even if the weather is nice. Some building can generate more cooling to relieve the stress on the grid. So that is called a more smart grid. So to the smart city, so it's even more interesting. So if we think about a city's urban energy infrastructure, or even the city infrastructure, there's a power system, there's a water system, right? There's a food supply. And then there's intercity or inter-county connections, because power line is connected within the same ISO. So then the question become, okay, what is consumption from the water? What is the water need for the people, right? And then also tie back to the transportation. If I know where people are at any time every day, so can I do a better optimization of the whole holistic system connected with power grid, the buildings, the water? So we used to have a concept, write a proposal before called building to water to grid integration, because heat pump from the water pump from the water generation is the largest consumer of the grid at all. So the pump for the water for the whole city is always running. It's the largest consumer ever for the utility company. Okay, that's it. So is it, if I know that's the water behavior, like how people use the water every day, right? So can we do better optimization? You know, it's still a system engineering problem. You know, it's a lot of states, you know, and a lot of control variables. And then the plus transportation, right? So there's a transportation study showing that, okay, we call it the urban mobility study, right? Well, I did some study on this as well. So I was showing the presentation as well. So what if I understand the mobility of people, right? And I know understand the transportation people use. Is it EV or it is not EV vehicles, right? So what if I know the EV charge behavior of the people back home? I know when people will charge EV, right? So can this also integrate with the grid? What if the grid has a blackout? Can I call all EVs to work together to support one low-income area and the disadvantaged area, right? So those are the, if you think about the smart city, those are the elements of smart city. The smart city need to have intelligent brain to make decisions while consider all different aspects of a smart city, from the urban structures to the urban energy infrastructures and to the urban transportation, the water supply, and the food supply as well. And then I also want to consider about intercity connections. So what if, you know, there's a big city, like say Philadelphia, right? It's a big city, and there's a different small counties around Philadelphia, right? So what if the power supply of one county is kind of blackout and can Philadelphia kind of supply extra energy into this, you know, county to make sure at least emergency is on. So those are things, you know, is a lot of thoughts and thinking, and it's involved a lot of both physics-based modeling of the different infrastructures and also data-driven modeling, because right now there are a lot of data available, right? So is it possible to combine both? So yeah, basically that's my definition of the smart at 3 different levels. Yeah.
Great, thank you, Ping. I think that's very helpful. You know, while you are talking, you know, kind of, I got this summary. I feel like, you know, when you know, whether it's smart grid, smart building, or smart city, essentially you are talking about developing algorithms and models that will support demand responsive control using information technology. Is that a fair summary of what you just talked about, like your definition of being smart? And making this system smart means that you can, you know, of course, through research, you know, by the effort from the researchers, we develop those models or algorithm. But the key, like the purpose is really responsive, you know, responsive yes. Control. Like you are talking yes. about control. Yes. And you are using technologies, you are using, you know, monitoring, you know, information system to better understand the demand. And yes. then you go either control, or you can even use predictive model control, right, to look at, so by working on those physical systems.
Yes, right? That's correct. Yeah.
So it's really an extension of the traditional control field, where now you extend to, like, you know, in addition to working on just control these physical systems, you actually go one step further to better understand the human behavior.
Yes.
That generates this demand.
Yes.
Right. So now let me raise our, you know, discussion a little bit higher, so you can see that right, with all these existing systems, our buildings, our transportation systems, or our grid, right, they have been in existence for centuries or decades, right? Our ancestors, how they behave, how they use buildings, and how they travel, and how they use energy. Now we feel that we are becoming smarter because, you know, you have sensors, you have all those technologies, right? So Bin, let me ask you a question. When you are trying to, you know, use all your research to make our living environment, including buildings, whatever cities, when you try to make those things smarter, what is your goal? What is your objective? Is your goal, at least for me, like, you know, you are basically, okay, we want to better satisfy, we want to better meet, you know, the demand or the needs of human beings.
Yeah.
Okay. But of course, you know, like in most of your research on your website or in many, you say that, okay, because our society, we're facing all these challenges because of urbanization, and of course there is greenhouse gas emissions. There is all these things, right? So, so you also care about the social goods. You can see that so far. You can see that your models, your effort is really meeting the demand, the natural demand of human beings. So my next question is, because if you look at our challenges, it's, you know, you're thinking about using technologies, using natural resources to satisfy this human demand. But there is one thing we all know that human demand is endless.
Yeah.
Right? Human demand is endless, right? It's kind of, for example, if let's say, you know, centuries ago, people can travel, say, at 10 miles per hour using a horse or whatsoever, or walking, like, you know, walking. And then nowadays you can see, by taking an airplane, right? You can flew, you know, across the Pacific Ocean, say, within a few hours. But even with that, what do people want? People want to be faster and faster. This demand. So my question is, what's your view about when we're dealing with all these societal challenges, especially sustainability challenges? What's your view about responding to human demand versus intervening and changing human demand?
Yeah, that's a very good question. Yeah, we tried this before. So, yeah, I talk about you know, the control goals, right? So basically meets the human demand. But at the same time, when we do this kind of research, at the same time we also do interviews and focus group of you know, people to tell them, to educate them what is inefficiency, right? So, well, how you don't need to put someone at 62 all the time. You can change it when you left the house. You know, that's what we educate them, right? So the overall goal for me, you know, I think is really to create a net zero emission planet. You know, that's the overall goal, right? So, but you have to start from somewhere. So I start from net zero energy buildings, right? So as you can see, one of the you know, there are a lot of technology available to make net zero energy buildings. You can retrofit, you can change the better roof, you can put PVs, you can put batteries. However, you know, well, the one thing is not easy to change is human behavior. So that's why you need to, you know, kind of, first of all, you need to understand human behavior and you need to design adaptive control system for human behavior. But at the same time, you also want to educate human being, educate the residents, like say, okay, you don't need to do this. There's a simple ways to do that. A lot of utility companies are doing that. They have different inefficient programs to educate people, right? And also, you know, there's smart thermostat like Nest and Ecobee. So literally detects the people when they are in the house, when they are not in the house, to better control HVAC, even they forgot. So those are the, so human behavior are very difficult to intervene, very difficult to change, because even if we use the latest technology, you know, there's a lot of strategies we used before. We try to, you know, give them Amazon gift card, right? So if you change someone's day, you get $10 or $20, right? Or you get free food, you know, for the low-income areas. However, it's very difficult to change. You know, without incentive, it's very difficult. Even with incentive, some people, they don't don't know, don't care, or they don't understand what's going on. So I think ultimately, education is a key. We have to educate people that, what is inefficiency? What is smart buildings? How you can do it together, with all the other people to make the city or our planet is more energy efficient or net zero carbon emission. Yeah. So I think that's my view on that. Yeah.
Wonderful. So essentially, you can see that. Thank you for extending this. So you can see that when we are dealing with all this, because energy is essentially, it's a consumer-driven service sector, right? So when we're trying to deal with this challenge, basically we're working from two sides. One side is the supply side, like most of the work you'll be doing, like making the building. It's really on the supply side. Having technologies to equip our buildings, and we can respond in a smarter way, right? So that's the supply side. Another side is the demand side management. So that you just acknowledge, it seems to be, as you said that, managing demand and changing human behavior, is difficult. So of course we can see that. So now as a systems thinker, especially based on your research, if I ask you about the strategic direction where our society should invest, not only our money, but also our effort in achieving, like for example, net zero planet, as you just mentioned, which side should we, which side will give us better hope and better bang per buck, supply side or demand side, or which, what is your take on that?
Yeah, I think, as I mentioned, we have a lot of technologies, innovations, right? So, but sometimes people don't understand at all what are the innovations and why should I do this, right? I give you one example. Even you give free thermostat, smart thermostat to everybody, I can guarantee you only maybe 50% people know how to use it. And the rest of people will, I just put temperature into what I want, like 65 all the time. Okay, that's happened to smart thermostat actually. So I think the investment in here, not only to technology, of course we have to invest in technology, but the most efforts should be invested on the education and let people know what's going on, how we can better build the planet, right? So that's I think that's the key. Have to educate people, have to talk to people, and from the social point of view to improve the holistic understanding of what is inefficiency, what is net zero and energy emission planet for everybody. Of course, the technology is already there. A lot of technology is already there, but the humans understanding, is not there yet. Yeah.
So you are saying that human understanding is not there yet. Is not there yet.
It's not there yet.
Yes. So so how do you feel? Do you feel confident? Do you feel optimistic? Human beings in the end, we are going to get there, or you feel pessimistic?
I feel it will take a long time, because it's generation by generation. I would think it will take a long time to be there. Yeah.
So of course, one thing is that, of course, you can say we are, yes, we have to remain optimistic. We believe that we can get there. But maybe we can pause a little bit. Let me ask you, have you thought about how we got here?
Yes. So the reason we got here is not because we invest a lot. Of course, we invest a lot in education, but we invest even more in technology innovation. So up to now, I think technology innovation is up to a certain bottleneck, because we have Internet of Things, we have a large we have capability of supercomputing. And we have GPUs, of course, right? We can do a lot of complex calculations. Even we have a content AI, right? Capabilities, so which is speed up, everything. However, as I mentioned, even the technology is so advanced without people understanding, first of all, how to use it, and second, I can tell you one example. All the building facility managers of the US, they only have high school diploma. they don't never go to university. Okay, say how they become a building facility manager? Building facility manager is a key person who actually controls the buildings. Okay, so how they get this job? A lot of time is from their father, who is building facility manager, and they I will be a building facility manager in the next generation by generation. Okay, so we have we used to, when I in San Antonio, I used to have a class, in the ASHRAE chapter, which is, talk to all the building facility managers in San Antonio. There's like more than 100 people. If you tell them, I want to do a smart control, everybody shakes their head because they say, smart control does not work. Why? I got complaints all the time with people who is not feel comfortable in buildings. So smart control will say, I put all the office into 72, but not all people want 72. So, and then I talk about, okay, what about demand response, right? So what about, demand response is you increase the temperature in the summer, utility company pay you a big check. And they say, oh, I don't know this. Half people say, I don't know there's a policy like this. Now half people say, not really work for my building. Why? Again, is the companies in these office buildings, they don't want to lose the comfort because they think comfort is related with productivity of people. If I feel warm, I don't want to work. So my productivity is low. And that's the most important thing, for the company. However, what if we change the energy policy? What if we say that, okay, your utility bill is super high and you have to consider that. Right now, the utility price is still cheap, because unless in California, there's a lot of companies in the demand response. But if we look at Texas, look at New York State, the utility price is still cheap. When the people thinking about, okay, the trade-off between the pay large bills and the sacrifice the comfort of employees, they will not sacrifice comfort of employees. They will pay small bills of the energy. They will use energy all the time. They will put temperature at constant 70 or even 72. So I think that, this is there is somehow the concept that there are a lot of investment into technology, pushing technology forward. People forget about what is what they sacrifice for. They sacrifice a lot of emissions. If you look at long term, in next 50 years, the carbon emission, right? They sacrifice that basically. They sacrifice the future carbon emission into today's technology investment. Okay, this is my point of view of that. Yeah.
Thank you. So as you said that it's kind of it's kind of be from a sustainability point of view. Actually, we're doing things that leave the challenge to the future generations. Actually, we take loans from future generations too.
Yes.
But
yes.
You're saying that, and I think you made 2 points. And one is that we're developing these technologies, and secondly, you mentioned that actually even we are developing technologies, but the development of our technologies nowadays is at a bottleneck. You seem to say that seems to be the key challenge in achieving, for example, carbon neutrality.
Yes.
By a certain point. So you're feeling that, okay. So are you saying that we should rely on technologies to help us resolve?
Yeah. We should rely on new technologies which considers human being. Right now, a lot of technologies they don't consider human being. Like the smart thermostat, they never consider about people's behavior, right? They never consider about your preference. And even the Nest, it will only consider partial of that. And also in large commercial buildings, like in your office, you never see a people counting sensor, right? You only see temperature sensor. You never see a people counting sensor. Does it know are you in the office or not? You never see that. It's not very common. So what I'm saying that the technology innovation, yes, you can have that, but you have to integrate the human aspect into the technology innovation.
Yeah. So I think, Ben, you mentioned earlier, like, your work, you did interview work with, employees, first from one, room, and then one floor and building, and then one city. Yeah. And then you say you did interviews, and I think you saw many interesting, probably, stories that on one hand could make you feel, oh, my work, it's really hopeful that we can reach carbon neutrality. On the other hand, you probably see cases where you probably feel very much discouraged. Wow, yes. Just look at how this general public is thinking. Let's face it, right? So, right, carbon neutrality, net zero, this is really a public good, while comfortness, any consumption, and my experience in the room, in the building, this is really the individual thing. So here, right, I just want to ask you a question about, so for example, assuming that all your wonderful work to make the building smarter is adopted by house, by commercial building, but still you can see that it's somehow at the individual level. Whether it's an individual organization or it's an individual, a citizen, right? So this is at individual level. So of course, for you to be able to convince these people to adopt your technology, you tell them that, see, my technology, my algorithm help you manage your system smarter. Right. So now my question is, since you do system control, system optimization, what's your view about the relationship between making our subsystem, making these individuals, whether individual person or individual organization, making this kind of subsystem at the individual level to be smarter, versus achieving the societal goal of becoming carbon neutral. So what do you see as this relationship? Because even you can see mathematically, you will, it's probably hard. For example, mathematically, if you say, okay, I can push my technology, I can make these buildings, I can make all these individuals to be extremely smart. And of course, when they are at individual level, if they're extremely smart, we all know that they are trying to pursue their individual objective functions. While somehow you can see that the individual objective function does not necessarily line up with the social goods. So how do you deal with that? So that's why it's kind of, so what I asked you earlier, how hopeful or how optimistic do you feel? And then what do you see as some key strategies that we can hopefully align, these things? Because at the end of the day, let's face, when you say, make something smart, you even use the word, buildings are dumb. You're treating buildings like a person. Yes, right. Of course, like, if you even think about it, when we educate ourselves, our own education, or if you have children, when you educate your children, right? Of course, you want them to be smart. Right. But so far, like most of the work you are doing, it's really, even including education, and of course, including both the supply side of technology and education of these consumers, these users of houses. You are mostly focusing on helping them become smarter in satisfying their needs. Again, this is responsive, but we all know that many outstanding people, right? They are not only smart in getting what they want. And a very important character they have is that they are very smart in disciplining themselves of what they want. Right. So, what's your view about this relationship between individual and societal goals, and how could we possibly address that?
That's a very good question. Yeah. So we did a project before looking at actually a lot of my studies is looking at individual behaviors instead of group behaviors. So we so in terms of controls, of course, what we do is we so-called individual personalized HVAC system. So that's the idea. So everybody got it their own temperature, airflow, you know, in the office, but that's super expensive. That's not possible, right? So what we did is at least, you know, 3 or 2 offices shared one HVAC system, one thermostat. I don't know if you have a thermostat in your office, but you know, normally it's 2-3 offices share one thermostat. So we still look at individual behaviors. And then we also look at supervisor level, which is whole building level, right? So in the control, we talk about this called decentralized control system. So basically in the high level, like whole building level, you make sure your energy is minimized, but also in the individual control level, you make sure you meet the, you know, occupancy needs, right? So this can be achieved in the mathematical form. However, it's difficult in the actual implementation. So because people's preference, like say I do a survey, okay, what's the preference temperature? 72. Okay, if I put 72 today, does not mean it's always 72 tomorrow. So people's preference of temperature, body temperature, is related with their emotion. It's more psychological impact of your brain. So if your brain is super excited, you feel warm. Like say I feel warm now because I feel excited. But if I'm quietly working on something like proposals, my body temperature is going down. So I prefer a different temperature. So it's more dynamic. So that's why, you know, it's difficult to balance the, you know, the, what you already talk about the disciplining yourself with your need and versus the social need. So the social need is we need net zero carbon emission, right? So individual need is I want my temperature to be this, okay? So mathematically it can be solved. You can do a optimization, decentralized optimization system. But actually it's very difficult to solve this. So the study I mentioned before, we did a so-called this incentive-based persuade study. So we give the $20 Amazon gift card to, you know, one office building, you know, gives them saying that, okay, can you reduce your temperature for like 2 degrees? You know, increase your temperature for 2 degrees in the summertime, which is you know, to relieve some cooling. And I will give you $20 Amazon card. Yes, they did, you know. And then later on, I give them like $10 Amazon card. Some people did, some people didn't, because they say, I want $10, I don't want $10. This is called self-discipline, okay? And then later on, we give like no dollars, okay? $0, okay? We want this same experiment happening. And actually almost nobody did that. There were 1 or 2 people did that. So you can find out, you know, the self-discipline of their need is very difficult. I really don't have a solution for that, but I feel a little bit frustrated when I did the experiment because the people just don't want to sacrifice their need, you know, as you said, discipline their need to meet the social goal. So that's why I think maybe education is, you know, important to emphasize, right? Make them understand. It's called social awareness. What is energy efficiency? What is the net zero energy carbon emission? Yeah.
That's very good. You know, I can totally understand, you know, the frustration experience, you know, when you saw those things. So now maybe it's kind of, let me go back to my question earlier. I asked, yeah, you can see that now people, you know, like the people get used to staying in the office with air conditioning.
Yes.
Right, they get used to it. And then if you take it away from them, they say, oh no, there's no way, because it's going to affect my, you know, productivity work, you know, affect my working efficiency.
Yeah.
So, and then the employer say, okay, yeah, to keep my profitability, let's keep these things, right? You know, who cares? Who cares about, you know, the social goods, right? So, getting back to my earlier question, I asked, how did we get here? Why are we ending up here today? That you see that? So using a case like when we educate our children, right? Children as they grow up, right? Of course, you see that their families, they spoil their kids. Their families, they discipline their kids. So at first, when the spoiled kids, like after they get there in their teens, even you tell them all the right things to do, but it's just too late, right? Because they're already used to that. Yes. And if you put yourself in their shoes, you can fully understand, because my life has always been this. Now you take this is really, it's real cruel, right? Why did you get me used to this? And now you want to take it away from me.
I agree, yeah.
Right, so now, so how did we get to this point? And what was the role that technologies play in getting us here?
I think the human being, first of all, human being tends to be survive in a more comfortable environment, right? They like more comfortable, meets their own needs, right? It's very difficult to discipline people. Like say you cannot use this temperature, you have to use another temperature. It's very difficult. So the thermostat air conditioning is invented in 1949. That's how the air conditioning invented. The reason invented is because people in Texas feel too warm, too hot. That's why air conditioning is invented, actually. so basically, human being cannot survive in a natural environment. Right? We talk about extreme heat. A lot of people died in the extreme heat or extreme cold weather. So that's why technology invented, and to bring us here at this stage that okay, there's a thermostat invented, there's air conditioning invented, and people know that I can adjust the temperature I want. And this is how we educated, as a child. That's how. And now with a lot of technology innovation, actually the thermostat does not have too much innovations. I saw a lot of buildings still use a thermostat like 20, 30 years ago, but they still work. And as long as you can put a temperature, it still work. So that I think that's how we getting here, because of we were taught and we are so adaptive to the comfort environment, and we cannot get out of this comfort environment, right? Comfort zone, we call it about this comfort zone. And also plus we know that the technologies out there can make us comfortable. Right? Before the air conditioning is invented, like before 1949, nobody used air conditioning. Then they have to survive, right? And a lot of people cannot survive because of extreme heat and hot. And also, actually, at that time, there's no extreme heat.
So let me ask you a question. Yeah. That's very, so it's kind of very interesting.
Yeah.
You say that air conditioner was invented in 1949. Right, and because for that you use a case like in Texas because it was just too hot.
Yeah,
it was just too hot, right? People, yes, in Texas it was very hot, but were people able to survive at that time? If air conditioning had not been invented, do you think that people, in Texas, without air conditioning, would they have been able to survive without air conditioning?
I don't think people, most people can survive, but some people cannot, because it's especially for elders, right? They cannot survive in extreme heat. Yeah, a lot of heat stress. Yeah. Okay,
that's good. So now let me ask you another question. Why today are, of course, next week there is, global climate summit. Why today, like you mentioned, similar, why today do you want to set it as a goal that you want to achieve net zero emission planet? Why do you want to do that?
Oh, because there's too much carbon emissions, which makes the temperature increase year and year, right?
Why do you care about that?
Why do I care about that?
Yes.
Well, it's a temperature increase is not only makes the temperature hotter, but when the temperature increase, it will also melt the ice, which is elevated sea level. So it's a cycle, basically. So if you elevate sea level, which will create a lot of flood, but also not only flood, but also a lot of natural disasters as well.
Why do you care about that?
Well, that will kill people's life.
That's right. So you're considering why you want to achieve carbon neutral planet is because you can see that climate change threatens the whole, the climate change threatens the whole humankind.
Yeah.
Is that reasonable?
Yes, that's a very correct statement. Yes.
So now let's two cases. Back in 1949, if we had not invented air conditioning, some people might not be survived, but the majority would be able to survive. But now, of course, we just use air conditioning as a representation of the technology, and then we invented many technology, including cars. Invented many things. Like actually, without cars, without air conditioning, human beings will still be able to survive. But now, due to the air conditioning, due to the cars, due to all this technology we invented in the previous decades or centuries, now we put our humankind as a humankind at the threat of the climate. So do you see the thing? If you if we sacrifice, if we educate, if we discipline ourselves and our whole humankind will still be able to survive. But if we keep indulging ourselves, right, while we make everybody comfortable, but the whole humankind will be at threat.
Yes, that's correct.
What you choose. And why? So now let me ask you, how did we get here, and why did we get here? And are we going to be able to learn lessons from why we get here?
I don't think, I'm not sure if we will learn lessons, because human being is very complex. From my point of view, yes, we will learn lessons, right? Because of technology innovation, which was increase the carbon emission, and also which create, students, right? Climate change and students to people's life. But what if, as you said, what if we don't invent cars, don't invent air conditioning, don't invent anything? We can still survive, which is true.
Yeah. So what's your view for the future? Are you optimistic or pessimistic?
Well, I'm optimistic enough that we will find solutions to conquer those climate changes. Yeah.
That's exactly, thank you. That's exactly, I think exactly like your, the way you just said, the view you just had, and also what you just said is exactly, I feel, where our hope is.
Okay, thank you. Yeah.
Yes. Thank you. It was great talking to you.
Yeah, me too. Yes. Yeah.
Yes. I know that you have about 50 more minutes left to prepare your seminar presentation. I don't think I want to hold you up, but I think we conclude our conversation, and I just want to thank you again.
Yeah, thank you, Oliver. Very challenging questions, very interesting. I never thought about in that perspective from human being side, how we get here. Yeah, very, very good question. Thank you.
Yeah, because you study human behavior, that kind of that motivates me to ask you those questions, because I think it's really, and you're right. You're right. In comparison to human behavior, thermostatic control is boring.
It's very boring. Yes. Yeah.
Okay.
Yeah.
Thanks, Bing.
Thank you. Yeah.
Bye-bye.
Bye.